Welcome. Let's take a look at how we might use a graph to help us answer questions about a function defined as a definite integral. In this case, we've got let a of x be the integral from 1 to x f of t dt, where f of t is pictured in the graph. So over here is a picture of the integrand. And the first thing we're asked to find is, what is a at 8? Well, a at 8 is the integral from 1 to 8 of f of t dt. So the first thing we want to do is identify the interval we're interested in. We're interested in starting here at 1 and ending here at 8. And we want to find the integral from 1 to 8 of that particular function. So what I notice is that on the left side of 6 being where the graph crosses the x-axis, my function is entirely positive. And on the right side of 6, my function is entirely negative. So it seems natural to break up that integral from 1 to 8 into two separate integrals, one on which the function is positive, so that would be the integral from 1 to 6 f of t dt, and the second being where the function is negative, the integrand is negative, and that would be from 6 to 8 f of t dt. Now, if we're to do that, let's go ahead and use the interpretation that the definite integral is the area between the function and the x-axis, actually the signed area. So this area that's above the x-axis will have positive sign, and this area below the x-axis will have a negative sign. Now notice that for the interval from 1 to 6, that we have a trapezoid as the geometric shape that is formed. So we can use the area of the trapezoid function or trapezoid shape to help us find the value or the area here. You don't have to use a trapezoid. You could do a square and a triangle, but it's more likely more efficient to use the trapezoid. So that is 1/2 times the two bases. The bases are the parallel sides. So base 1 has from 1 to 6, so that length is 5 plus, and then this other base is from 1 to 4, that has length 3. So 1/2 of base 1 plus base 2 times the height. Now this trapezoid has a height of 3, so we will multiply by 3. Now, 5 plus 3 is 8, and so we end up here with 24 halves, or more simply 12. So this first value is 12 plus, and now we turn our attention to the second integral, this area that lies beneath the x-axis. And this is the integral from the integral from 6 to 8 of f of t dt. This particular shape is a triangle, so we can use the formula for the area of a triangle. The base of the triangle is 2. The height of the triangle is also 2. So we'll have 1/2 times the base, which is 2, times the height, which is 2. And when I simplify that, Well, actually our height is -2, or you could throw the negative on at the end. But in either case, the value of this definite integral is -2. So we end up with 12 plus a -2, so that is equal to 10. So this function, a of x, which is the integral from 1 to x of f of t dt, has a value of 10 when x is equal to 8. Next, we want to evaluate a prime at 8. So to be able to evaluate a prime at 8, I need to first know what a prime of x is. So a prime of x is going to be the derivative with respect to x of the integral from 1 to x f of t dt. And now we can rely on the fundamental theorem of calculus to help us find this derivative. I'm simply going to take my integrand and evaluate it at this upper limit of t. So this would actually end up being f of x. So a prime of x is actually equal to f of x. So a prime at 8 is equal to f at 8. And recall that f of t, our function f, is pictured here in the graph. So locating where x equals 8 on our x-axis, we can come down and find what the function value is at x equals 8. And that function value is -2. So a prime at 8 is equal to -2. I hope you find this helpful.